One of our subscribers recently made the comment that I sound like I am bearish on AI and asked that I make a video talking about whether I'm bullish or bearish and explaining my views. So this is obviously something that is super hyped in the world today. And so let's give a realistic assessment of AI, where we're at, where we're going. And as a result, am I bearish, bullish? What exactly does that mean? So let's dive in. Before we do, if this is your first time here, welcome. I'm Michael from Offshore Citizen. We are experts in international corporate structuring, so helping you to set up your company, to do business in multiple countries, taking advantage of what that might mean, lower payment processing rates, lower taxes, better banking, better payment solutions, et cetera, as well as relocating to other countries and everything that comes with building plan Bs and asset protection and all that. So if any of those things are interesting to you, please reach out to us. You can send a message through offshorecitizen.net on our website, or you can book a call with me, calendly.com/Michael-Rosmer. There's a link in the description below. Okay, so let's talk about AI. The first thing I would say is I think people tend to, unfortunately, as with most things, sort of polarize. And so you're like bullish or bearish. If you're not extremely bullish, if you don't believe that AGI is going to be here next year, maybe you're bearish or something like that. This is unfortunately the way that people tend to categorize, and that is just not a very good way to look at things. It's much more useful to be kind of specific and precise and have subtlety and nuance in your views, in my opinion. And at the same time, I think that the way that people reason about AI is typically fundamentally flawed. And what does that mean? It means people sort of ascribe this amorphous quality to AI, which isn't that hard to relate to because it feels like a bit of a black box. You put stuff in and magically something comes out and you're not really sure what's going on in between. The danger is when you have something that you can sort of amorphously paint in a certain way, it kind of inherently means that you can rationalize a lot of stuff that just isn't accurate. And so to think properly about AI, I think it helps to be really, really granular about what's actually going on. And then you can start to pick apart and tease out what is real, what's not real, what's going to be coming, what's not coming, what the consequences of what is already here are versus what is coming in the future. So that's what I'm going to try and do a little bit in this particular conversation. The danger of all these mental models, I think, where you can sort of rationalize things away is like you really don't want to think that way. So how do we think about AI? You should not view AI as a thing. Definitely not as a magic thing, definitely not as some amorphous thing. You should consider it on the spectrum of automation that started sometime around the Industrial Revolution. So starting in the Industrial Revolution, we started to automate various different things. And essentially, as our technology has advanced, the spectrum of things that we could automate has expanded. Partially it expanded because of different power sources, partially it expanded because of interchangeable parts, partially it expanded because we had more precision tooling, partially because of the fact that we could just get better engineering, partially because of the introduction of electricity, and then basically transistors, and on and on and on, right? There's been this gradual process of increasingly automating more and more of our lives. And that's a generally good thing, right? Generally, it means that it frees us up to do other things, and it is a lever for kind of having more outputs in our lives relative to the inputs. Very good. AI should be viewed as nothing more than a continuation of that process. And why that's important is because when you start to tease it apart and when you start to focus on the individual components, what you discover is there's certain things that it's really good at, and there are certain things that it is really bad at. And I'll give it kind of a common expression that I think is absolutely ridiculous, which is posing something like, when will your AI be smarter than you? I'm like, I don't quite understand when people say that sort of a thing, because if you're granular about it, your calculator has been smarter than you for a very long time. Like, you just can't do long multiplication and division in your head nearly as effectively as the calculator can. That's just the way that it goes. Do you somehow, from that process, get the idea that this is, smarter than you? Well, it's smarter than you in like a very narrow way. chess computers have been way, way better than normal human chess players. In fact, exceptional human chess players for a very long time. Long before AlphaZero, which is kind of the very famous Google DeepMind chess computer that came along and could self-learn and was really wonderful, computers were destroying. Magnus Carlsen is the kind of best chess player in the world right now, longtime world champion. He kind of retired from that a little while ago, but incredible, incredible. You can go and watch him on YouTube. It's amazing. And so that, like, just because it is smarter than you in this, does it mean that it's smarter than you? Does it mean that it's not smarter than you because it's not smarter than you in other things? Like, how do you even parse that out? You can't really say, oh, it's smarter or it's not smarter. Certainly, if you were to go to ChatGPT or Grok or Gemini or Claude or something like this today, and you were to just start asking it things, it could answer way, 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 way more things accurately than any living human, okay? The kind of collective information that it is managing to store and retrieve really quickly far surpasses what any human is capable of. You just do not have the sort of the storage capacity or computational capability in your brain to be able to do that. Is it smarter than you? Well, it's really dumb at certain things. So you can go and you'll notice that it just makes really stupid mistakes often. The types of mistakes that a basic intern or something would not make. So is it smarter? Is it not smarter? Again, it's just one of these very imprecise questions or imprecise statements that people are making that causes us to develop a mental model about how the world works that is just not accurate. So I try to avoid thinking that way, and I would recommend that you also avoid thinking that way. What I think you need to consider is you need to consider that all of this automation deals with a basic principle, which is you put stuff in and you get stuff out. So you have inputs and outputs. And what you're attempting to do is you're attempting to expand the surface area, the complexity of the inputs that you can give and the outputs that you can get. And so up until we had these kind of neural nets and large language models, et cetera, the types of things that we could automate were generally limited to the things that we could build heuristics around. That essentially we could create some sort of a flow chart that would say, if this, then that. And within those things, we've been able to do automation pretty well for a while. The problem is, a lot of things, the complexity becomes so great and expands so quickly that it's just totally impractical for us to be able to build this type of heuristic. You can maybe try in certain cases to come up with loose laws that are adaptive and things like this, but driving is a really good example, right? There's just so many edge cases driving that even though driving is in theory relatively simple, I mean, your 16-year-old kid can learn to drive and do so pretty quickly, pretty easily, pretty well, all things considered. Humans are actually like remarkably effective at driving. And yet Elon Musk has been saying that this is the year of self-driving since 2016. And by 2025, it's getting pretty good. If you've never been in one of the Teslas with full self-drive, it's pretty good. But it still makes mistakes that humans would never make. However, it's also way more responsive and way better in certain things than humans are. So again, is it better? Is it worse? Well, what it is that the surface area of possible scenarios that it can deal with is not as broad as what a human can deal with for, you might say, for whatever reason, or maybe for a variety of reasons. And so that's just a kind of an example. Now, what you'll find is that normally the way that these things learn is you have to give them a lot of data. So you have to give them a lot of examples where you can show input A equals output B, so that it can kind of learn this pattern matching, and it can kind of form out, okay, these are the characteristics that define A, and that way we can define the characteristics of B. And if you think about it, language is a really, really great example of this, where ChatGPT has come along and really amazed us in kind of fooling us at its degree of intelligence, because the set of patterns that you can put in and the coherent patterns you can get out are incredibly complex compared to what we're used to in sort of heuristic, like flowchart type way of thinking, okay? So they're really good at that. Now, does that mean that they are able to take over everything or going to take over everything? No, absolutely not. Let me qualify that. Not in the near future. The way that they work have certain fundamental limitations. And you can reason about this pretty easily just by realizing how they're trained. So let's start with the most basic thing. LLMs, if you're thinking of them just purely in terms of words, and so we'll kind of separate aside for a minute world models and their ability to learn on other types of language, the stuff that you might call language, are learning about the world through language. And this has some inherent problems. So when you learn language and when you learn about the world, what you do is you map language to real things. So I'll point there and I'll say, this is an apple, this is a tree, this is a this. And your brain is kind of forming a connection to something in the real world. Fundamentally, an LLM trained on all the language in the world never has that conception. By definition, it learns about tree in relationship to other words, okay? And what we know about language is quite a coarse abstraction for the world. In other words, when you say tree, that encompasses a tremendous variety of different objects. It's a very broad class. And that's kind of useful for us as humans because we don't have to pry into the little individual intricacies of things, and we can function in the world with relatively quick learning. But from the standpoint of precisely defining what's going on, that is not so accurate when you were thinking about it from a linguistic standpoint. In other words, when I tell you tree, it doesn't tell you that much about the real world. When I point to a specific tree, that tells you a lot about that tree, if that makes sense. So this is one kind of piece that is there. Now, there's definitely attempts, and they're definitely working on increasingly building these world models. So you have people like Jan LeCun, who is the head of the AI program at Meta, who is a very famous AI researcher who has been working on this. I mean, a lot of people are kind of pushing in this world model direction. And the world model direction just clearly has some degree of extra distance that it can go compared to looking purely at language. There are other problems with looking purely at language. For example, when we're talking about hallucinations. Hallucinations are sort of intrinsic in part because of the ambiguity of language. It's just sort of an inherent thing that is going to happen when you're looking at things purely linguistically. Now, technically speaking, you might say, well, LLMs don't actually look at things linguistically because what they actually do is they take this language and they break it all up into little pieces and it encodes those into a very high dimensional vector space. And so LLMs don't actually think in terms of language, they think in terms of basically linear algebra. And there's some truth to that. There's actually a set of problems that arise from there because it is difficult to map the fuzziness of language onto the precision of numbers. There's a whole bunch of different things you can look at. For example, there's something called quantization that is being done at Tesla and at some other places since then. Normally what you would have is you would have essentially an array of many, many numbers that represents some particular piece of information. Let's say a token for simple examples. And so there's some encoding, which is a large set of numbers. And that set of numbers might be 16 or 32 bit. So it'd be what we'd call a floating point variable. And so it's got a lot of information in it, essentially. I hesitate to say that because I've gone through this whole information theory thing over the last while, and Claude Shannon probably wouldn't define that as information. It's a string of characters. But anyway, without kind of getting into over complexities about that, let's just call it information. So there's it's a large string. And what they've done is they've realized they can strip that back to like 8 bits as opposed to 16 or 32 bits. So that's, a lot less information, 256 values as opposed to about 65,000 in the case of a 16-bit, or it's like 4 billion in the case of 32-bit. So, in those cases, you might say, okay, well, this is the case, right? So why can they do that? They can do that because there are certain cases in the world where precision is not really necessary. So for example, it doesn't matter the exact shade of red that a stop sign is. It's red, and that tells you all the information you need to know. And so you can use less precise values. So, there's all sorts of different attempts. There's also different things where you'll actually inject deliberately some sort of randomness, some sort of kind of stochastic variable around the embeddings. And there's a bunch of reasons why that gives you some advantage when you're building out these systems. But the point is, language and math, like numbers, are kind of inherently precise, and language is inherently fuzzy. And these are both different methods of abstraction that we use to represent reality around us. But when you have this fuzziness, you're inevitably going to run into cases where multiple meanings can be injected into different places, and it can kind of lead you down different paths. So there's a certain effect that is going to take place there. Now, a world model helps, but does a world model actually get you to the end state? There's a bunch of reasons why that in itself, even if you can kind of accurately model the world, has some clear differences with what we do as humans. Now, let's be clear. It is also equally important to note that computers don't inherently have to think the same way that humans do in order to get comparable or perhaps superior outcomes. So, we may find a totally different way to do it. But what we definitely know is that the way in which these systems are learning doesn't seem to, they just clearly don't learn so quickly with such little data. That's essentially the basic concept. So there's another problem which comes in here, which is a mapping between inputs and outputs. So sometimes it's very easy. And so, for example, I was on a call with some people in one of the companies that I have today, and we were talking a little bit about building code. And we're kind of pushing, we've got a tech team, and we're pushing them to use more LLMs, more AI to do their coding. And I went and did a bunch of tests a few weeks ago. I basically built an entire kind of primitive but still functional accounting system in like a day with Google Anti-Gravity. And the CEO who we have for the company had gone and built out his own little thing in a relatively short period of time. We're just talking about like the capabilities of these systems, and they're really amazing. Like, I came away from doing a day of kind of vibe coding with this Google Anti-Gravity, and I was like, junior developers are screwed. Like, this is going to be really bad for these people, because why would you hire them? I can understand the value of a senior developer. There's still a whole bunch of things where coming in and cleaning it up, etc., it's quite difficult to do on its own. Much, much better if you have coding experience to be able to make some of these changes, to be able to verify, whether the proper design patterns are in place, whether there's correct security there, etc., etc., etc. But it's gotten really, really good. It is remarkable how much you can do. And Andrej Karpathy, who is like one of the leading AI people, brilliant engineer, has recently done a post on Twitter commenting on how he has never felt so behind as a software engineer as he does now, because just the advancement in tools in the last 6 months has been remarkable. All true, all true. The thing about it is code is pretty simple language. So the expressiveness of code, it's kind of been bottled down in this way that it only works in certain ways. It's relatively easy to parameterize the inputs and the outputs. And so, of course, it is like the fact that code is kind of the most structurally precise language. Obviously, you're going to get a computer system that will be able to code really well as compared to a bunch of other functions it can do. Interestingly, this is actually quite different from something else which we might have taken for granted as having done for much, much longer, which is writing stories. So if you ask an LLM to write a story for you, they're remarkably bad. And the interesting thing here is, if you ask why are they remarkably bad, it's not because they don't have good use of language. Their language is far better than my language. Their vocabulary is better, their sentence structure is better, their grammar is better, their spelling is better, etc. Like, they far surpass me and most humans in these regards. But the problem is, in order to get them to be good at writing a story, we have to be able to define what good is. And this is very much a moving target. There's very much a element of not just how the individual relates emotionally to the piece of art, but what the societal context is. So what is popular in one period of time might be off-putting in another period of time. So how do you define what is good and what is not? And there's been work on this. There's a company called Epigogics that quite a while ago was putting together an algorithm for evaluating the success of movie scripts and a whole bunch of this stuff. There's been attempts quite successfully to do things around music. So it's not to say that these can't be figured out in one way, shape, or form or another, but there are, when you're just thinking about complexity of input to complexity of output, and then you have to say, okay, I need I need a large enough sample space in the side of the inputs that you can derive patterns in those inputs to the outputs in order to be able to learn what patterns of inputs will trigger what outputs. Like you need that. And there's just a lack of this in a bunch of regards that make it virtually impossible for these machines, based on the current methods, to figure this out. Now, can they figure it out? Of course. Obviously, like, the fact that humans can do it means there's obviously some methodology there, right? There's obviously something that can be figured out. And there will come a point in time where computers are better at doing it than we are. And you'll be able to duplicate them virtually instantaneously at virtually no cost, and that will be pretty phenomenal. The technology is not nearly there yet. There's definitely a variety of fundamental breakthroughs that are necessary in order to cross that bridge. And it's worth understanding kind of some of those key distinctions in how they function to how people function. So there's a line that Bullish gives, which is, AI is middle to middle and humans are end to end. In other words, we're good at specifying what are the things that we want done, what are the kind of objectives, and how well did you do relative to those objectives. And then a lot of the AI systems are good at generating the in-between. Now, there's a whole bunch of things that they're still not that good at, right? You'll notice that if you try even to develop a piece of code, you'll ask it to change something, and okay, it fixes that, and then you find some other problem, you ask it to fix the second problem, and it breaks the first problem again. Like, there are some things that they do that are simply not so good that a human wouldn't do, right? There's sort of a different way in which they're approaching it. And that will improve. Like, one of the things that I was mentioning to this friend today is, listen, these systems are remarkably good at coding, and they are the worst they will ever be. 6 months from now, they will be better. 12 months from now, they will be better still. And so that's pretty cool. That's amazing. Like, I can tell you, when I sat and I spent this, it was a lengthy one day, doing this coding, I was like so empowered. To me, it felt wonderful. It was like, I can make anything. This was like kind of the sentiment of it. Of course you can't. Of course there are limitations and challenges. And if you start getting into a loop of fixing problems and stuff, it can become frustrating. But it's very, very empowering. And that's like really wonderful. So am I bullish on AI? Well, I'm bullish on AI to radically increase the capacity of people to do coding. That I'm definitely very bullish on. Like, that is already here. Most software engineers, like, I will kind of say this anecdotally just from looking over our soft dev team, are radically underutilizing it. It is already way ahead of what most software engineers are using it for. I mean, Andrej Karpathy says that, and he's like super top, right? So that should tell you something. That's really wonderful, and that's going to happen. Self-driving cars have gotten pretty darn good. Pretty darn good. Are they 100% perfect? No, but they're pretty darn good. And so, all right, will we get to like real full self-driving in the not too distant future? Pretty close. You might have like the odd period of time when you need some kind of an intervention, but pretty close. They will be very, very good. Are there a number of other things? Like, I think about lawyers. Lawyers are pretty screwed. Why would I call up and deal with a lawyer at this point in time when it's so much faster? Like, by the time I have arranged to have a conversation with them, I can have 10 conversations with ChatGPT. Now, it can make mistakes, and so it might be worth it to do all that research and then call the lawyer and go and verify the final outputs. But this is a role that is, frankly, going to be greatly diminished. A lot of analysts in different roles, of course, going away. So there is a subset of the roles in our world which are imminently at danger. And I don't think that's a bad thing. I think that's a good thing because it is empowering to, like, there's a much larger subset of people who will benefit from that than the people who will be hurt through having to retrain and move into other professions and things like this. So that's a relatively good thing. Now, what about going from there to, okay, they're just going to do everything? No, like that is a very hard problem. That is a long distance. If you hear people like Elon Musk coming and saying, here in the next year, 5 years max, it's probably much longer than that. This is like just, experts are not very good at making these predictions, especially when they're raising money for a project that is professing that they're going to do these things. So that's just, I'm deeply, deeply skeptical of AGI. Again, AGI, the problem with it is, how do you even define AGI? What does that mean? I've seen people who are like, oh yeah, well, I mean, these systems, they're AGI. You're like, really? I don't know. They like fail deeply at a bunch of different stuff. I wouldn't really say that they're AGI. So like, there's a big gulf there. And I don't expect, so when you might say, am I bearish? Well, I'm bearish the idea that that will come in the near future. Meaning, I don't think that we will be remotely close to that in 5 years. I think that far from the narrative, which I did a Twitter post on this the other day about, I don't know, the danger of exponentials or something like that. And I was just talking about how there's this idea that we have of exponential growth. And people sort of are used to being told this narrative that, oh, people are really bad at predicting exponentials. They think linearly instead of exponentially. And the problem with that is most things actually aren't that exponential. Very, very frequently, things move in S-curves. That's like the more common way that things develop. And people are told so much that things move in exponentials that they start to track things forward in exponential terms. And then they end up being way off the mark in their predictions. It's very, very rare that you see true exponentials. Like Moore's law held up for a long, long time in actual exponential improvement, and that was a rarity. Swanson's law has been pretty good about holding out, say, in the cost of solar panels and things like this. That's worked out fairly good. Now, neither of those are limitless. You hit some sort of a point where there are simply natural constraints of physics that hold this back, but those are the minority. And I think you can already see, there's like, from my view, a little bit of an AI hangover starting to kick in, as people were told, oh, this thing is improving exponentially. If it's this great this year, imagine how great it will be next year. And for the most part, average people's experience with AI, whether you're on GPT-4 to GPT-5, is more or less the same. Gemini 2.5 to Gemini 3, more or less the same. It turns out Gemini 3 is much better. It turns out GPT 5.2 is much better. But it's much better in specific areas that most people will not notice. And within those areas, you hit rational limits pretty quickly, math being a really good example. So traditionally, AI was not very good at math. It was quite bad at it, actually. Kind of weird how that's the case, because you would think that computers, you know, they're fundamentally mathematical. But the way that they would process the information was just totally different. There's some really interesting papers from Anthropic tracking the difference between what the AI told you it was doing versus what it was actually doing. And it would tell you, oh, I did this, which was the common way of explaining how you'd actually do the problem. And then what it was doing was this very bizarre process, completely different than that. Not necessarily a very efficient one, by the way. But they've gotten really good. If you just take a picture of an equation and put it into Gemini 3 Pro, there's like a very good chance it will solve that problem for you pretty quickly and pretty accurately. The problem is, you know, once you hit 100% accuracy on that particular piece of mathematics, you can't improve beyond that. There's like a natural limit that you arrive at. And so when you're kind of in these narrow areas, yes, you get an improvement, but that improvement, like, it naturally kind of tops out. And this is kind of similar to what we saw with smartphones. Back when smartphones were first coming out, or I guess particularly when Android started to take off, I was really interested in smartphones. I would follow all the latest releases. I was really on top of it. And I was super excited because everything was changing all the time, and that was great. But what you quickly found was that these sort of topped out. You know, the batteries got good enough, the cameras got good enough, the processors got fast enough, the memory got large enough, the screen resolution got good enough, et cetera, et cetera. And now, you know, you maybe upgrade your phone every 3 or 4 years because it's like, wow, it's not really that big a difference from one year to the next. And I suspect you'll see something very similar when it comes to a lot of this AI. It has improved very quickly, and in certain vectors, it continues to improve quite quickly. But in a bunch of vectors, it's kind of the same, you know, it's kind of commoditized, doesn't really make it that much better. So that's something to think about. There was this thing that got put out, somebody had sent it to me, AI 2027. Terrible, just like complete trash, total garbage. These people like were living in some sort of a deranged fantasy land. I don't know whether they're like pushing for some sort of a particular intervention or something, but it was this whole like takeoff scenario where we're gonna have, you know, basically the world taken over by these superpowered AIs in 2027, or we're gonna end up in a huge war and, you know, stuff like this. And it was just like deeply delusional about the capabilities of these systems, the progression of these systems. There's kind of this idea that they would begin kind of self-training themselves. And it's like, it's this idea, again, it's the problem with the amorphous idea of AI. You think, oh, of course, it can just start improving itself, and the better it gets, the faster it will be able to improve itself, and you'll run into this exponential. The problem is it just doesn't work that way. Like I said, math only improves until you hit the point where you've correctly solved the equations. Okay, maybe you can say there's like a broader idea space in terms of formulating new theorems and proving theorems and stuff like that, which, by the way, it's not particularly good at this point in time. And that's like quite a bit more challenging of a field of study. The stuff that we do at Offshore Citizen, we're doing often some like really complex tax planning. I can tell you the AI is not particularly good at those outlier things. It's fairly good at validating those once you bring them up, but it's not resourceful about piecing out to something that is not within the normal realm of experience. And you'll see something similar if you go and try to use it for looking at stocks. So if you go to pick any of the major LLMs and you say to them, I'm interested in building a portfolio of stocks between 8 and 12 stocks that will do at least 10x in 10 years. I want the highest risk to reward composition of these. Please go through and build me that portfolio. What it will come back to you with is entirely consensus. It's the stuff that if you were to just go online and be like, oh, what are the highest performing stocks going to be? This is like the list that it will come back with. By the way, some of which are like good companies, but there is no sort of first principles understanding that does what you should do, which is to say, okay, let me first build a list of all the stocks in existence. Like it basically can't find non-consensus stocks. It's not very good at that at all. And in fact, if you think about it, fundamentally, what large language models are consensus algorithms, because they are trying to predict the next token. And so what does that mean? They're not actually building a model of how the world works and then reasoning from first principles about what happens based on that model. Instead, what they're doing is they're saying, what is the probabilistically most likely thing to get said about this? And it's generating a string of language. And that string of language tends to be coherent, and it also tends to be fairly accurate in a large set of spaces because of the fact that what people would actually say would actually be accurate, right? So you're not going to talk about, I don't know, having a sun on top of the table, you know, like you just wouldn't talk about that. And so it's not likely to output that because that's not how people talk, and that would be incoherent. And so the way that people talk generally is reflective of the world around them, which means that if they're talking the way that you're talking, they're likely to talk in a way that seems coherent to the world around you. If you start giving them questions about spatial representations within a room, and you start describing like one person over here and somebody over there and things like this, you'll notice that they very quickly start to run into problems because they don't understand the world. That's not how they work. They understand representations of language relative to each other and then predict that forward. And yes, you can layer on direct experiences of like, okay, hey, this is a tree, you know, and okay, it can learn to depict a tree. There's like kind of a famous thing that's a problem where if you go and ask one of these models to generate a full glass of wine, it like has a huge problem doing this, because there's like no pictures of wine glasses that are full of wine. It doesn't have a concept of wine as this thing and full as something, and like it struggles with these types of representations. It's kind of deeply embedded in the way that they build this out. And so do I believe that eventually we will get to a point where we kind of progressively solve these issues? Yeah, absolutely. Again, the fact that we as humans are able to think the way that we do is proof that it is possible to recreate, like, you know, you are a bundle of chemistry, essentially. And so that can clearly be synthesized in some way, shape, or form. It's like how we were able to do AlphaFold. So it's not that it's an unsolvable problem. It's that people bring the future way closer to the present than it actually is. They don't really have a very deep understanding of what it takes to solve complex problems. And they tend to, there's a very common problem that happens in sort of predicting the future, which is when somebody has never done something, and I don't mean somebody, I mean like it's never been done, right? Never been done. We tend to think, oh, well, you know, if we were to just have 5 years, we could do this. But the truth is you have no idea. A really interesting example of this is quantum gravity, or kind of anything related to the unification of gravity and quantum physics. And so there's this inherent conflict within physics. We've known about this for a very long time. And it was a problem they were working on a ton. Sort of the standard model of particle physics was developed in the early 70s. And by the 80s, they were pretty big into string theory. And if you had asked a lot of people what was going to happen in that time, how long would it take, they probably would have radically overestimated. And by the way, these are like the top experts in the field, right? If you'd gone to Ed Witten, who's like, you know, arguably the most brilliant physicist alive, somebody, the only physicist who'd ever won a Fields Medal, you know, really incredible thinker, he probably would have overpredicted what would have happened by quite a lot. It turns out, fast forward to today, there's almost no progress on that problem. And so you're like, well, hang on, what's going on there? If you were to go back to when we first landed on the moon, people would have said, oh my gosh, you know, by the 80s, for sure, we're gonna have, you know, an elevator to space, and we're gonna have all sorts of things. Well, guess what? Space travel, like after the first few missions, they didn't go back to the moon at all. You can get into the whole conspiracy theory of did you actually go to the moon? Let's set that aside for the sake of this argument. And space travel basically like froze until SpaceX came along. Like costs didn't come down, you didn't have more missions, you didn't have like it's just, there's sort of these derangements in the way the world works in reality as compared to how people like to conceptualize it. And I think it's super important to think of it in terms of reality. Like, you want to try and think of the world as it is. So I'm not worried at all that most of the jobs are going to disappear in any time in the near future. We absolutely do not need to worry about universal basic income. Elon Musk's thing about we're going to have universal high income is absolutely delusional. Like, it will not happen anytime in the near future. At some point in time, probably will you get robotics figured out, and you'll have robot maids and things like this, and robot chefs, and will that be wonderful in a certain regard? Yes, absolutely, 100%. How long will it take? Well, it's not going to be next year. It's not going to be really in the next 5 years, very likely. These are like really hard problems to solve, and then once you solve them, the scaling up of it is really hard. So that's, I guess, what I would say. Like, does that make me bullish? Does it make me bearish? I mean, I think it's a really useful thing in certain areas of life, and it's not useful in some other areas of life, and it's going to be deeply disruptive to certain professions and not deeply disruptive to many other professions. And we will probably eventually get to some sort of a AI that is more reminiscent of how people are in this kind of end-to-end way that biology talks about, that doesn't make kind of these same sort of mistakes that an intern wouldn't make. But those problems are going to take a lot longer to solve than the people who are busy raising money for their large companies would have you believe. And so, I don't know, does that make me bearish? Does that make me bullish? I think it's a wonderful technology. I think that a lot of the companies in that space are really overvalued. I think that, them applying a $40 billion valuation to thinking machines is absurd. I passed on investing into SpaceX or into XAI, and actually OpenAI both. Might have been a mistake because I hadn't, my failure was to consider that I could just exit on secondary. So that was, one kind of little bit of an argument around that. But I just viewed that where you're at, the risk, et cetera, it's not a great risk-weighted return. And, it might turn out that that was a bad call, but I suspect that a lot of these valuations have peaked. You kind of hit peak AI hype in that regard. And it's a little bit like what happened with the internet, right? When the late 90s were there, people said the internet would change everything. And if you were to fast forward today, it's true that the internet is intertwined in our lives all over the place. But it took like 20 years. And you will see AI intertwine with all sorts of areas of your life, but it will take 20 years, 30 years. I sometimes tell people this story when they tell me all the jobs are going to be replaced and all this sort of thing. I'm like, no, that's not going to happen. Or when I say that's not going to happen, the question is always about timeline. In a short timeline, that's not going to happen. And it's not even because of technology, although I just mentioned a whole bunch of technology problems that I think exist. But I'll give like a very, very simple example of like how real life works. And all these technologists don't seem to get it. If you want to go and get an EIN for an LLC as a foreigner today in the US, you need to fax a form in. Okay, just like consider the absurdity of this. It's 2026 and you have to send a fax. Now most people haven't had fax machines in like 20 years. So that just seems utterly bizarre. And you might say, well, surely we have the technology not to do faxes, right? Surely you could do email. At least you could do, we literally had email since like, the early 90s, earlier, something like that, a long time. You've had relational databases for numerous decades that you could store this information in. You've had web browsers since the 90s. You can build web forms to enter this information in. There's absolutely no technological reason why you should have to fax something in 2026. Zero. But it is the reality. That is literally how these things work. And there's a lot of things like this. A lot. There is so much that you can just go into various different companies and you can rebuild their systems from the ground up and you can make them highly efficient. Go and log into your bank's online banking portal. For most banks, it looks like it was designed in the 90s. It probably was. It's really bad. It's really, really bad. Why? Is it like a technological limitation? No, it's not a technological limitation. There's a really interesting book, Men, Machines, and Modern Times. And they talk a bit about some of these things, like the reason behind the reason that things don't end up happening. And you'll have like the technology, you will have the capability, but it doesn't take place. And so part of the pessimistic side, the kind of bearish side of me, is just that the cultural, political, organizational, social changes that need to take place to integrate these things into real life are really challenging and take a really, really long time. And that means that a lot of the effects of this technology are going to be decades out. You're not, like, you just have zero worries that, oh my gosh, you're going to have, I heard Andrew Kang making comments last year about Jobageddon. And I was like responding to him just like, no, you will absolutely not have this Jobageddon. It's not like you're going to have just destruction of the workforce. This will not happen. It won't happen, first of all, from the stuff related to AI. There will be like certain specific sectors. Like, look, right now, everything that people tell me who are in the software engineering space is that in particular, people, junior engineers, et cetera, are having a very hard time getting jobs. Totally accept that, totally believe that's a case, et cetera. There's going to be a variety of sectors that experience that. Probably similar to what happened in other fields when you introduced various levels of automation into them. Normal. It's the increase in the spectrum of automation. But that spectrum of automation is also going to push out our capacity, which is going to create a whole bunch of other jobs. Will that offset enough? Hard to say. How long will it take for people to retrain? Traditionally, people don't retrain very well. This is what we've seen. There's a certain economics view that, oh, it's perfectly fine to have this comparative advantage between countries because when people lose their jobs over here, they can go and do something more valuable. And in reality, they don't do anything more valuable. That is kind of the way that it goes. There's a good book, Good Economics for Hard Times, where they talk a little bit about some of what goes on here. This is a bit of what happened in the Rust Belt in the US and kind of the hollowing out of that whole area, is people do not tend to retrain. People are not that adaptive into new areas. People do not go and relocate to the places where they are most valuable. It's a nice idea in economics, but it's just not reality. It's not how the real world works. And you should learn to think in terms of how the real world works. So that is my conclusions on AI, fairly lengthy, but let me know what your thoughts are. Put them in the comments below. Again, if you need help with any of this international stuff, please reach out to us. And otherwise, I will look forward to seeing you on the next video.